Hey, what's up guys? JC here, and I wanted to take this time to explain what everything in Betaflight does. Now, I know there's a lot of new guys in this hobby, and whenever you first start off, this can be very overwhelming, so hopefully this will give you a better idea of how everything works. I do want to apologize for the misleading title. I can't teach you how to use Betaflight in one video because that would be a 10-hour long video. But instead, if you look in the description below, I've left a link to my Betaflight playlist where you will find how to do everything in individual videos. So first up, why am I talking about Betaflight? Well, out of all the different configurators, you have Baseflight, which came first, then CleanFlight, which was a little bit better, then Betaflight, we now have Raceflight, and we also have iNav. Baseflight is completely outdated. No one no longer uses that. Some people still use CleanFlight, but Betaflight, in my opinion, is much better. Now, if anyone chooses to use CleanFlight, I have nothing against that. It's all personal preference. I just like Betaflight. iNav is geared more towards large GPS builds. It has a lot more GPS features and functions. And Raceflight is the newest, and right now, because it's still so new, at least at the time of me recording this video, it's okay. There are a lot of guys using it, but it's not finished. Now, the Raceflight 1 project is almost complete, so if you are watching this video at a later date, then Raceflight 1 might be around. Who knows? So where do you get Betaflight? Just go to your Google Chrome store or whatever, and just do a search for it, download it there. Once you have it downloaded, the next thing you want to do is make sure you install both of these drivers. Certain flight controllers require a certain driver. If you don't know which one you need, just download them both and you're golden. After you've done that, then you need to flash firmware, because when you purchase flight controllers, they don't always come with the newest version. Not only that, but they don't always come with Betaflight firmware. Some of them come with CleanFlight firmware. Like I said, just look in that playlist and you will find videos on how to do this. Now if you connect, you should be seeing a picture of a multi-rotor, but I don't, because I have a custom motor mix loaded into my flight controller. This is going to help with the flight controller's algorithm for controlling the motors to give you better performance. Almost all flight controllers have a accelerometer. I would even go as far as to say maybe all of them do, but not all of them have a magnetometer. The magnetometer, you only need that for GPS builds. But if you're using Betaflight, I would assume you are not using a GPS build, because otherwise you would be using iNav. Now the accelerometer is for if you want to use all three flight modes. You have angle, horizon, and acro, and I will talk more about those in a second. If you only fly in acro mode, then you don't need the accelerometer, and you can disable it to lower your CPU load, because the lower the number, the better. Here you can see some basic statistics, like your battery voltage. This is if you have a current sensor, either in a PDB or in your flight controller, or you add in an external one. Then you can see the current drawn and all that, and then RSSI. You do have to set all these up and have videos showing you how to do that as well. Ports, this is for adding in different devices. Data will be if you were using an external on-screen display. Logging is if you use an external black box type logger, but most people are just using the black box feature built into Betaflight. Telemetry is if your transmitter and receiver supports telemetry. This allows you to see your battery voltage, current, RSSI, and many other sensors on your transmitter. RX will be if you're using a serial-based receiver like S-Bus or iBus or something like that. This does not include PPM or PWM. And GPS if you want GPS. Configuration. Here you can choose what type of frame you are using. It comes, the default is just your normal X-shaped quadcopter, but you can change that here. Mine says custom because, like I said, I have a custom motor mix loaded into it. Here you can choose what types of ESCs you're using. Now, if you're watching this video at a later date, D-Shot ESCs at the time of me recording this are around, and I have been using them with a pre-released version of Betaflight. But if you are watching this in the future, you should be able to look in this drop-down box and see a D-Shot option. This stuff here, this is going to be your preference, whether you want to separate the motor PWM speed from the PID speed. This is if you're using like air mode or not. This is going to tie in heavily whenever you calibrate your ESCs, and you also want to change your motor idle speed if you are using air mode. You may have noticed an arrow on your flight controller that points to the default front of your flight controller. This does not mean you have to mount it with the arrow pointing to the front. You can mount your flight controller any way you want and change the orientation here, and that is going to change where the flight controller thinks the front of it is. I don't ever mess with accelerometer trim because most transmitters nowadays actually have the trim switches. Here you choose what type of serial or what type of receiver you are using. This allows you to see your voltage in your telemetry and on-screen display. Every flight controller has a different way of setting this up, so there isn't like one specific way, as well as the current sensor. If you don't have a current sensor, then you might as well leave this turned off. It will give you a value, but that value is wrong. I also have videos showing you how to calibrate both voltage and current. GPS, if you are using GPS, your gyro update frequency and PID loop frequencies, I definitely recommend learning how to set this up because it's going to vary from flight controller to flight controller. Also depends on what type of ESCs you are using, because you can overload your CPU and have, say, like a CPU load of 100%, and then your multirotor is going to lock up. It's not even going to arm, or even if it does fly, it's not going to fly well at all. It's basically going to commit suicide. Here you can turn on your various sensors if your flight controller supports those sensors. This allows you to calibrate your accelerometer in flight. Servo gimbal is going to be if you are using a camera gimbal connected to a servo, like a 2 or 3 axis gimbal, usually tied into like head tracking modules, stuff like that. Soft serial is they're basically really slow UARTs like the ones we saw in ports. You can add in even more devices if your flight controller supports a soft serial port. Sonar is if you add in a sonar sensor. If you're using Betaflight, once again, you probably are not, because that's what the larger GPS build guys are using. Telemetry, if your transmitter and receiver supports telemetry to allow you to see all of your different sensors. 3D is if you're using 3D like ESCs. They can reverse direction, allowing you to turn upside down and then like fly up, but you're upside down. It's pretty wild stuff. LED strip is if you have addressable LEDs added into your flight controller. This is if you add in an external OLED screen display. Black box, if you want the black box feature to be able to log, it basically records everything your flight controller is doing as you are flying, and then you can go back and review that log using the Blackbox Explorer. And what this is going to do is it allows you to see what is going wrong, and you can make adjustments in the PID Tuning tab to get better performance out of your multirotor. Channel forwarding, if you do use servo outputs. Race transponder, this is really, a few flight controllers have this, specifically the SP Racing flight controllers. If you race on a real racetrack with a timing system, then you can add in these IR LEDs, enter in a code that comes with your flight controller in the race transponder tab, and it will actually, it's a cheaper and lightweight alternative to adding in an external race transponding system. Air mode, this allows you to keep control of your motors even if your throttle is at 0, which a lot of guys that does freestyle flying, stunts and stuff like that, air mode is what everyone uses. And OSD, Betaflight does have an OSD feature, and that's only if your flight controller has a built-in on-screen display and it's compatible with the OSD feature. Moving on to Failsafe. By the way, if you don't see all these tabs, one, you can enable expert mode, and that's going to let you see the tabs, or even more tabs than you normally would. Also, let's just say LED strip. If you don't see LED strip, it's probably because you don't have it enabled. So I actually don't use all of this. Really, the only thing I use is air mode and OSD. I just have these turned on just so you can see the tabs. But anyway, Failsafe. This allows you to, by default, it's set up to, where if you fly too far away and you lose signal between your transmitter and receiver, then your multi-rotor is just going to drop to the ground. But you can set this up to land safely. This is actually, I was going to say difficult, but it's more scary than anything. You basically have to find at what percentage of throttle your multi-rotor uses just to hover, and then you want to go a little bit below that, so whenever you lose signal, it will default to that throttle setting and it will hover its way down to the ground for however many seconds you set. The problem is if you accidentally set this higher than the value that it hovers at, say like 1300 or something, when you lose signal, it's actually going to fly away from you and you're probably never going to see it again. Also, if you're really high in the air and you lose signal and it is hovering down slowly, and say you just have it set for 10 seconds, after 10 seconds the motors are going to turn off and it's just going to drop down to the ground, even if it hasn't made its way to the ground yet. But I just leave it on drop. That's my personal way of doing it. PID tuning, you will spend a lot of time on this once you start getting into tuning your PIDs, because this isn't just something like the other tabs where you can just turn stuff on and off and it's just going to work. This is actually like, there's a very steep learning curve and you will have to play around with this and come back into it and then fly again, then change some things, fly again, change, fly, change, fly. It takes a very long time to perfectly tune your multi-rotor fly at its full potential. So you got your PID settings, you got your filter settings, you also have three different, basically you can have three different settings. I don't know how to explain it. You can change your PIDs and have three different saves, and then you can go out and try all three and find the one you like best and then modify all three again. Same thing for your rates. You can also change different PID controllers. The PID controllers just work a little bit differently. Some people prefer one over the other. And you can change your throttle mid and expo. This allows you to have more control closer to the center of your stick, or like hovering. It just gives you more control over your multi-rotor. And TPA breakpoint. I won't go into that in this video. Like I said, just check out my playlist. Receiver.
Hey JC, welcome back.
Once you have set up your receiver in the ports and configuration tabs, then you can test it out here to make sure everything is working. You can also have, you can place your RSSI into an on-screen display using this page here. If you are using a receiver with a little bit of jitter in it, then you can fix that here. Your different modes, you can arm using the sticks or with a switch. I prefer using a switch, so I create a switch for that. If you want your three different flight modes, you can do that here. Angle is the easiest to fly. It self levels and everything, makes it super easy. The flight controller is basically correcting all of your mistakes. Horizon, well, with angle you can't do any flips or rolls. It won't go past a 45-degree angle. With Horizon you can do flips and rolls, but whenever you're just flying around normally, it self levels itself kind of like angle. And then the third one is acro. It's the hardest one to use, but that's what everyone that's doing these stunts and freestyling is using, because you have full control in acro mode. You don't see acro mode because if you don't choose one of these, then it automatically defaults to acro. Mag, head free, head adjacent. This is going to be for your GPS stuff. Failsafe, you can create a switch to make it automatically go into failsafe if you choose. You can also turn on a beeper, you can turn on your black box, and different stuff like that. Once again, if you're not seeing all of this, it's probably because you don't have something enabled. So, for example, you won't see both of these flight modes unless your accelerometer is enabled. Adjustments. Some people, whenever they tune their PIDs, they will log in the black box and then they will go back and review their log, and then they will make their changes in the PID tab. But another thing you can do is actually set up switches to be able to tune your PIDs in flight. I wouldn't say one way is better than the other, it's all personal preference. Servos, you probably won't use this ever if you're using a multi-rotor at least. Now the fixed wing guys, yeah, they do use this, or if you have a multi-rotor with like a gimbal and head tracking, then you can set up head tracking through this. Motors, this is where you test out your motors, and you can also calibrate the motors. At least if you have one-shot 125 or multi-shot. D-shot, you don't have to calibrate them. So if I plug in a LiPo battery, I can test them out here. You can check to make sure they are spinning the correct direction. You can also make sure that they are calibrated correctly. And if you do need to make any fine tunes, you can't make the fine changes through here. You would actually have to use the Betaflight suite. And I do have a full playlist showing you how to use this. And you can also do many other things through here, like change your motor direction instead of having to physically flip-flop wires. You can just do it through software. You can also use your ESCs as a lost model alarm or a beeper using the beacon and beacon delay and many other things. So just check out that playlist and you'll learn how to use the Betaflight suite. The OSD, like I said, this is only for flight controllers that have a built-in OSD, and it's supported by Betaflight. A lot of flight controllers have built-in on-screen displays, but they use a separate firmware, so they are not compatible with this. But here you can turn on many different things and set up your on-screen display just the way you want it. You can even click this, drag it around, and have everything just where you want it. You can also set what type of camera you are using, whether it's PAL or NTSC. Choose your warnings. The text will flash on your screen if it goes below these warnings. For the race transponder, like I said, if you do purchase a flight controller that comes with one built in, they also send you a code, and you enter that code in here and get it working that way. LED strip. Just watch my video on setting this up. There is a ton of stuff you can do with addressable LEDs. You can practically make them do anything you want. Sensors, I use this page for when sometimes if a motor is acting very strange and I'm not sure if I have a bad motor, bad ESC, or sometimes it's a bad sensor. So this is the very first test that I do. I come here, I test the gyro and accelerometer. Mostly just the gyro because I don't use the accelerometer, but you can take your multirotor and move it around. If any of those lines are just staying straight, they're not moving, then it's probably a bad gyro or accelerometer. If everything is good, then I move on and test the ESCs and motors and all that. But this is the first thing that I do. Tethered logging, I never use this, and I am willing to bet that 99.9% of you guys are not using this either, so I'm not even going to talk about it. Blackbox, almost all flight controllers come with a built-in like flash chip that can hold a certain amount of memory, and using that switch in the modes tab and also enabling Blackbox in the configuration tab, you can record everything your flight controller is seeing as you were flying. And like I said, after you make that file, then you can take that file, go into the Blackbox Explorer and review the file, and then that will actually help you tune your PIDs in the PID tab. Now the newer way people are making flight controllers is instead of using the built-in flash chip, they're actually adding in SD card readers, and you can insert up to a 32 gigabyte memory card, because the flash chips only hold between 2 megabytes to 16 megabytes. Some hold 32, some hold 34, but I'd say 16 to 32 is the average, and it's just not that much. Not only that, but they can't log as fast. CLI, this is where you can, everything you can do in all these tabs, you can actually do manually through the CLI. And I guess let me explain first. So you see all these neat little switches and boxes that you can just type stuff in, and all of these that you can choose. It wasn't like that a long time ago. And what I mean is like the base flight configurator, or even before that. But over time, they start adding in more and more things, more of these switches that you can just click, and more boxes that you can just type numbers into. But before, you actually had to do everything by hand, and you have to like memorize how a bunch of this works. But thankfully, they've added in a lot of this to make life so much easier. Now, it's not perfect. There are some times when you will have to use the CLI. I actually use the CLI a lot in my videos, as I'm sure you will find out. Just for example, there is no box for entering what you need to have that custom motor mix. So you will actually have to come to the CLI and do it by hand. Another thing guys do is you can do a dump all command, and they will actually copy and paste all of this and then place it into a notepad. That way, if their flight controller ever gets damaged, they can just replace the flight controller with another one exactly like it, and then re-upload all this to it so they don't have to redo everything. You can also see what version of firmware is on your flight controller. And you can do other stuff like the status command. You can see your CPU percentage and all that, and or you can even do version to see what version of firmware is on your flight controller currently. I always check this whenever I buy a new flight controller to see if I need to flash new firmware or not. Sometimes my beeper gets really annoying and it beeps at times when I don't want it to beep. So you can go to the beeper list and manually turn off certain instances where you don't want it to beep. And it just goes on and on. There's so much stuff you can do in the CLI. And that is pretty much going to wrap it up, guys. That's I know this video was long, but I mean, that's as short as I can make it, to be honest. So I hope you have a better understanding of how the Betaflight configurator works. Not only that, but if you can figure Betaflight out, then you can also figure out Raceflight and iNav and CleanFlight, because they have some differences, but they're all very similar. So that's going to do it for this one, guys. Like I said, look in the description below for that link to my Betaflight playlist, and I show you how to do everything that you want to do. So thanks for watching. I'll see you again soon.